Hey guys, welcome to this quick video where I will be showing you how to publish a very simple JSON Rest API using Go. We're going to start off rather quickly here in a file here called rest.go. This is going to be the file that runs our REST server through the net/http package. So we're going to go package main, and I'm going to start by importing well, I know I'm going to be using the JSON package, so that's encoding/JSON. And I'm going to quick save there because I'm in Sublime, and I have the nifty automatic Go fumped when I click save. Speaking of fumped, we're going to import the fumped package as well as the net/http package for this tutorial. So first things first, well, we're going to have a main function at some point. I'm going to leave that blank for now because more importantly, we're going to have a, well, actually, I'm not going to leave it blank. Let's start off by, we're going to be creating a web server. So that's really easy in Go. First thing we're going to do is we're going to call this function called http.handlefunc, which is like one of the simpler ways to sort of publish something with the server. And this function that's going to be handling that /request, which is pretty much everything, is going to be a function that we will define later, but I am going to call it serve rest for now. And then this main program is going to listen and serve, which I'm going to make localhost 1337, and then the handler for that is nil for now because we have the handle func. Okay, so now we have to define this function serve rest. So this function, because it has to implement the interface, or it has to match the handle func interface, I think the handler interface in the HTTP package. And in order to do that, we need a http.responseWriter, and we need a pointer to a HTTP request, just like that. Okay, so this function is going to write to the response writer, and so I'm gonna need to serve JSON to that. I'm gonna need to write some JSON to that response writer. So what I'm gonna do is just say response gets the, I'm going to make a function called getJSONResponse. Might as well separate this out a little bit. So let's define that before we move on through that function. So we're going to have another func called getJSONResponse. And so what I'm going to be doing is serving JSON. So let's back up a little bit here. I'm going to define some data structures here that we're going to be putting into a JSON package quite easily. Let's start off. I'm going to define something called a payload, which will just be the JSON, like the main, like this sort of struct will contain everything. Say that it has some stuff called, which is of type data, which I'll define in a bit. And then we're going to define data here as another struct. And for the sake of this demo, let's say we're tracking information about fruit, which is going to be of the type fruits, and veggies, which is of the type vegetables, for the hell of it. And then since we have those types here, I have to define them further. Fruits is just going to be a map of, let's say, strings to int. So type string to int. And you'll see how I use this all in a bit. So hang in there. Oops. I don't know what that is. Veggies. So type vegetables, which we're saying that veggies is of type vegetables. Vegetables is also going to be a map of string to int. There. Okay, so now in our getJSONResponse, let's arbitrarily fill some information in about those fields. So we'll say fruits. Let's make a map. This is how you make maps in Go, is you call the make function. It's one of the ways you could do it, I think. I'm not sure how many there are, but, and we're going to make a map of strings to int, of course. And then we're going to fill that up. Let's put in, let's say that apples we have 25 apples, and just copy this real quick. Actually, no, I'm not. And let's say that we also have oranges. And let's say we only have like 11 oranges. Okay, so now let's create a vegetables map. So map of string to int. And we'll put in here, oops, automatically capitalize that for me. Let's put in here carrots. And we have 21 carrots. And then we'll also have peppers. And let's say we're completely out of peppers. Okay, good. So this is just our arbitrary data that we're going to be serving. So now our data struct that we have. So if you notice, these two maps that we've created are in this data struct. So let's create a data struct with the fruits and vegetables. Yeah, vegetables maps. And then this data, we look at our structure, and this is all arbitrary, by the way. There's many different ways you can format your data, is in a payload. So let's define a payload as a payload, and we'll put D in that payload. And now, finally, for the really easy part, we have to return some JSON, right? Oh, and that actually reminds me, since we're returning, well, here, I'll show you in a bit. I have to put a return value, but what I'm going to do is I'm returning JSON dot, we're marshalling up the payload class, or not class, the payload struct. And just for your information, JSON.Marshal returns two things, an array of bytes, or a slice of bytes, or a byte slice, and also an error. And so those will both be returned with the response, and we're going to handle them in the serve rest function in a bit. But there's the normal marshal, which just serves it as like a unformatted blob of JSON. But for the sake of this demonstration, I'm going to be doing the marshal indent function, which takes a couple more arguments, but is essentially the same thing. So we're marshaling up the payload struct here. So we put that there. The prefix is just, we don't really need a prefix, so I'm going to make that an empty string. And then to be visually pleasing, the indent, I'm just going to do 2 spaces for now. So that's going to return the slice of bytes. We're calling that from here. So now, oh, well, we have to say that it's returning a slice of bytes in here, and also an error. Okay, so that's good. And then now we have to handle those 2 function arguments here. So we'll say response error is get JSON response. And for, obviously you want to handle your errors better than this, but for the sake of this demonstration, we're going to say just panic if we get an error. And then now all we have to do is write to the response writer, and we are in business, I believe. So to write to the response writer, I'm going to be using the fprintf function, which just writes, it takes a writer, something that implements the writer interface, which the response writer does. So that's W. And then we want to, so we have a response here as an array of bytes, but we don't really want to write, I don't even know if fprintf takes like just a slice of bytes. So we're going to, as a string, we're going to return the response, just like that. Okay, now if I haven't made any errors, this is a fully functioning web server, actually, which is really neat. So let's test it out over here. Here I have my rest.go function, go run rest.go. Oops, what is this? On 40. Oh, I forgot to declare that. There we go. That's the beauty of having to compile something, right? So you notice that nothing's happening, and it's blocked here. That's because http.listenandserve is a blocking function that's serving. So let's go to our localhost port 1337. And here you see we have our JSON automatically formatted and everything. You know, it's publishing these two maps, which get published as, you know, in the JSON form with the Marshal function, and it's really neat. So now I'm going to do a flip side of this, and I'm going to actually consume this API or this REST API in a second file. So let's do that for now. I'm gonna just let's write let's call it consumer.go, right? And this is actually really easy. And you'll see that pretty much the exact same, I'm just gonna copy and paste the, we just need the same exact structure as before. But first, let's do this package main, because it's just gonna run on its own. And for this package, we are going to import the encoding/JSON package just like last time. We're going to import the fumped package. We will be using the net/HTTP package to grab the, you know, to grab the payload here, pretty much from the local host. And you'll see why in a bit, but we're also going to import the IOUtil package, which is a really sort of a convenience package in the IO package that really makes it easy to sort of open files and stuff. So you'll see in a sec here. So we just need a main function for this. Oh, and we need our structure from before. So we'll just copy this over. Now, you know, you can imagine that you could do this from another computer or in a different language, computer language, but we're just doing it in Go, so it's the exact same. So, you know, here in our main function, we are going to create a URL string that we'll use, and the URL is going to be localhost 1337, right? And then response and error, we're going to call the http.get function, which just takes a URL string and gets it and returns an error if there is one. And we're just going to throw that error away for now, pretty much panic with it if we get one, because I'm not expecting one. But, you know, obviously this is bad for if you were writing, you know, anything more than just a simple sample program. And then this is the neat thing about, you know, one of the neat features about Go is the defer function. So we're going to need, so we've opened up this file pretty much from, you know, the network, and we want to close it if, you know, for any time we leave the main function, we don't want it to stay open as a reference. So we're going to defer the response, or the body, and we're going to close the body here. Oops. I got to buy the Sublime on this computer here. Lastly, what we want to do is read that body into a usable format. So we're going to call the IOUtil function, and it's a function in the IOUtil package called readAll. So we'll just say body and error gets IOUtil dot readAll. There it is. Returns, or it takes a slice of bytes, which I believe we can just throw response.body would fulfill that. So we're just trying to read the body of the HTTP response, which is going to be our JSON, by the way, and put that into this, you know, body variable. And if there is an error at any point, obviously we can panic, but do that. Okay. Now, what we want to do is we want to unmarshal that body into a payload, and you'll see how we do that in just a sec. So let's first declare a payload, which we have defined already from here. You know, it's got stuff internally, which has, you know, which is of the type data, and the data type has the fruit and the vegetables, which we've all defined already from before. But in this case, we're going to be grabbing it and filling it in from the JSON REST API that we've published already. Okay, so now we're calling a function called JSON.unmarshal, which it does exactly what you think it does. And we're unmarshalling the body here. And we're going to unmarshal that into the P, which is the pointer to the payload struct. And then if we get an error, then we'll panic with it. I'm not expecting to. But then lastly, let's just see if it worked. So we will print out p.stuff. Oops, that should be the fruit, and we'll maybe a new line separated so it's easier to see. And also the p.stuff.veggies. All right, so let's go through this one more time. So we're creating a URL. We're grabbing a response from the URL, which is going to be our raw JSON in a URL or sort of a response struct that's an HTTP package. And then we're going to grab the body from that and unmarshal the body into a payload, which all works like magic, honestly. Well, I say that, but I hope it works. So yeah, let's see if this has worked. So I'm gonna go and run the REST server in the background, and then we're gonna run the consumer here. So we'll just say go run rest.go, put that in the background, and then go run consumer.go. And it worked. So you see here that it pulled it into a Go map of apples and oranges, carrots, peppers. So it actually did work. So we're obviously still serving the JSON here, but this program grabbed that JSON and transferred it back into a map, which you can do over the internet or whatever, which is really neat. And it's very simple to do in Go and very, very cool.